Good morning, my outstanding friends. I am going to take a new approach to how I present my research. I'm going to go every day to these. There's a couple of different sites that I have, Science Tech Daily, and there's another one, Science Alert, that tells you what's going on in the science world, what everybody's talking about day by day. So I'm going to go through their articles every day and make my comments. And I'm not going to be on the same page that they're on because I don't go along with peer review. I have an opinion and I have some evidence to show. So when I have my opinion, I will always, virtually always, back it up with evidence. And my evidence is going to support my claims, and my claims will not be their claims. I can virtually guarantee you that. Okay, my friends, get ready. This is Science Tech Daily, and this is 11th of November, 2023, Webb's window into cosmic birth. How are planets created? What creates planets? They call it ice pebble drift. Sparks planetary life. Like I said, I am never going to be on the same page as them. Now, this is the Webb telescope. And here's what they see, is they see these rings around these, what they consider to be developing planetary objects. Now here's what they're saying. Drifting pebbles deliver water to the inner regions of planet-forming disks. How are planets born? Scientists have long proposed ice-covered pebbles are the seeds of planetary formation. The ice solids are thought to drift towards the newborn star from cold, remember this now, cold outer reaches of the disk surrounding it. The theory predicts that as the pebbles enter the warmer region closer to the star, they release significant amount of cold water vapor, delivering both water and solids to the nascent planet. Well, where did all that stuff come from? Where did all that stuff come from? And I'm going to tell you exactly what they're claiming here, and it's happening here. It happens on every planet. There's extreme cold out there, and there's extreme heat out there. They're not even thinking about that. They're talking about this is artist conception. This is what they think, and they're showing it compares two types of typical planet formation disks. Well, I'm going to go into what really does form them, but what they're looking at is the main planet, basically, and then these rings that surround it. And what are those rings? They're the exact same rings that surround planet Earth. All right, listen to this carefully. They're saying the confirmation of theoretical predictions. Right? A fundamental prediction of this water pebble theory is that icy pebbles enter into the warmer regions. So they're out here and they're icy in the snow line. They enter into the warmer regions where ice transitions to vapor, so it melts basically. They should release large amounts of cold water vapor. Exactly what Webb observed. Yes, that's extremely obvious. It happens here on Earth too. It's the exact same thing. Webb finally revealed the connection between water vapor in the inner disk area and the drift of icy pebbles from outside into that water vapor area, said the principal investigator Andrea Bazzotti of Texas State University, San Marcos, Texas. This finding opens up exciting prospects for studying rocky planet formation with Webb. Well, you just look at Earth, it's exactly identical, same thing. The outer water is frozen, basically, and the inner water melts and turns to rain. Okay, this is from NASA, and they put out this Webb Space Telescope that's out there seeing the images undistorted from Earth's interaction with these fields. And look at what they're seeing out here. These are the images they're sending back, and they are quite spectacular. And they can see a very long way because of the design of this particular telescope. But look at what they're looking through. You see what they're looking through, all this stuff? That's not just empty space. That's absolutely not empty space. This is saturated, literally saturated with dust and debris of all types. And also, light itself is a particle that I've shown hundreds and hundreds and hundreds of times. So, and they know this. It's not something that's unknown. Light pushes things. It pushes solar sails. You shine light on a Crookes radiometer and it spins. It impacts, and it creates huge fields. And all these particles have to impact these fields. And I'll show you the fields. They don't even show the fields here. They just show all these particles. Well, every one of those particles has a field. Every single particle. All right, let's start with what is a space telescope. A telescope, you know, it sees very long distances by using these focal points. Well, they put these out in space so that the atmosphere does not disturb the light coming at it. They think it's a vacuum out there. You put it out there and nothing is going to disturb it. No, it's not, obviously not a vacuum. I just showed you it's absolutely saturated with particles. So what they did was they took the Hubble Space Telescope. Here's the deal right here. Hubble is right around the Earth. It orbits the Earth and it looks out all over the place and sees all kinds of things very clearly. I have no complaint with that. But then they put Webb out here orbiting the Sun. See what it says here? James Webb Space Telescope is not in orbit around the Earth like Hubble. So Hubble is here. It actually orbits the Sun 1.5 million kilometers, which is 1 million miles away from the Earth. So it's quite a ways away, not being disturbed by all the Earth's atmosphere. However, the Sun has a ton of disturbance as well. So it's away from the Earth at what is called the second Lagrange point. Okay, so I'm going to show you what is in space and all of the fields that particles have to navigate themselves through. What they're doing here is fine. It's nice to be able to see way out there, but you have to understand what you're looking through is not a vacuum. All right, you see all these different layers of the atmosphere, and there's going to be a distinct difference in temperatures between each layer. Let me show you what it actually looks like in temperatures. Okay, so they want to know what sparks the birth of planetary life. Well, and then they show these pictures of these different zones that surround the planet forming. And then they talk about the water and these ice pebbles drifting inward, creating moisture. And the first time they've ever seen this and so forth. All they have to do is look straight up in the sky. You see it every day. This is nothing more than exactly what's happening on Earth. All right, I'm going to show you some diagrams in a minute, but listen to what they say. How are planets born? Scientists long proposed that ice-covered pebbles are the seeds of planet formation. Well, first of all, where did they come from? Where did their ice come from? If they're out there, that's fine, but they had to come from somewhere. These icy solids are thought to drift toward the newborn star. So they're ice and solid out here. They're drifting down towards the planet from gravity. These icy solids are thought to drift down toward the newborn star from the cold outer reaches surrounding the disk. The theory predicts that as these pebbles enter the warmer region closer to the star, they would release significant amounts of water, cold water, delivering both water and solids to the planet. Well, all that's fine, and that does happen. But where did all this stuff come from, first of all? And secondly, they don't understand gravity. This is gravity, and they don't understand that it is scrubbing out here, creating the energy that forces these particles together as a gravitational attraction, and they have regions of bounce. Boom, 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 boom. That's how it goes. It hits out here, it bounces back. It hits down here, it bounces back. You have hot, cold, hot, cold, hot, cold, and then you have to hit the planet. See, here it is right here, unraveling the mystery. For 2 months, we were stuck on these preliminary results that were telling us that the compact disks, the closer ones, had colder water, and the larger disks out here had hot water. That's because they're the ones that are scrubbing. And the colder water is just an offset of the hot. Hot has cold. They work together. It made no sense because we had settled a sample of stars with similar temperatures. They were all going to be the same. So it's outwards where it scrubs, because everything apparently is moving, and it's scrubbing through the atmosphere, which is saturated with particles. So the outside gets hot, and as a result the inside gets cold. Then the next layer is the same thing again. It goes to a hotter region, then a colder region. The bigger the thing that's in space, the bigger it's a planet, let's say it's a planet, the bigger the planet, the more rings of impact there's going to be. Now, let me show you what they're showing. All right, don't forget they're saying it's hot out there, then it gets colder, then it gets hotter, then it gets colder. Yes, and here's what it does on Earth as well. Okay, before we get started, I want you to understand we're not like on a record player just spinning around like this. We are being dragged through the arm of the Milky Way, and the sun leads all the planets behind, and they spin around the sun as we do, following the sun's being dragged by the arm of the Milky Way. I'll show you this in a second. What's scrubbing off the side of the sun, I will also show you in a second. We can see those particles, and they're being ripped into our pathway, banging into us. And that's creating our scrub zone as we spin through those particles. Now remember, we're spinning around this way, moving forward through whatever's in front of us, and the more stuff that comes off the sun is the more stuff that's going to be in front of us. And there's also a ton of stuff in front of the sun, because the sun is plowing through that. All right, so then we all plow through that and spin through it. So we're heating up, and we're getting charged up because these are charged particles. All right, so let's continue on from there. Don't forget now, we're being dragged on the arm of the Milky Way, so let's look at that. Okay, so my claim is that all particles are dipoles, and it's called dipole electron flood theory, and that there's ether. They always used to call it the ether particles in space. That's known since antiquity. And it is true. There's nothing but particles out there. There is no vacuum in space, not whatsoever. Now remember, we're being dragged through on one of these arms, and we're spinning like this. Everything spins like that. Light spins like that too. For some reason, and I can't tell you the actual reason, but it does. So everything that's coming forward here is spinning and being dragged behind the sun, scrubbing. All right, and it's all turning into a tighter and tighter spin. And that's what a galaxy does. All right, so we're coming through here, plowing through whatever's in front of us, and there is a ton of stuff. So we're being scrubbed. We're not into a vacuum. All right, this is a total solar eclipse. The moon is right over the disk of the sun, and we can see all these intense spots and the magnetic interference around them. These are the sun is spinning in that direction, scrubbing like crazy as it plows that direction. This is the slough off side. See it sloughing off here, just sort of plowing away. This is shooting out spikes like crazy and highly impacting. So my point being is these are all charged particles. When they leave, they're gone, and they just filter through the universe, and they are in all kinds of different sizes. Now, my claim is that a proton is not like that. A proton is 1,823 small dipoles. I've shown this so many times, literally thousands of times, and this goes back to long ago. And I've had this evidence to show these particles for close to 10 years now. And these are what's in space, and they just disregard them like they're not even there. Well, obviously they're there, and they cause enormous fields. All right, here's the problem with what CERN, Fermilab, and Lawrence Livermore, all of them are doing, is they're using protons, big heavy protons and neutrons, colliding them together and seeing all this stuff come out. Well, this is nothing more than a proton right here, only it's 1823 dipoles. And these dipoles are light, okay? Two dipoles together like that is a photon. I'll show you this very carefully. We use photons. When we collided them, we could only see the tiniest particles. We didn't have all this trash. So we could see the actual interaction of the small particles. They saw all kinds of chunks. They see chunks like this. They call them X particles. They see little 4 bangers and 6 bangers and 2 bangers and singles and all different colors, and it's just a mess. Now, when we see it, we can actually see the actual particles. All right, here they are right here. This is what a photon looks like. And there's 2 dipoles. That's all it is. That's all it is. But this is 1823 actual dipoles. So there's 1823 of these black and whites in one proton. So when they slam them together at CERN, and they just see all kind of debris, but they have found these are, yes, absolutely, the smallest particles they can find. And they call them a fixed particle, which never changes size, and a point particle, which gets big and small and has all the energy. And here it is right here. These are the ones we found. It's exactly identical. There's no difference whatsoever. No difference whatsoever. And even they claim it has a glowy edge around it, which it does. You see the glowy edge around it? And the white particles are the ones that have all the energy, and they can squeeze down to almost nothing. And they have no mass to speak of. Almost no mass whatsoever. These are massive, and they never change size. And they're bowling balls. They're pushers. They're carriers. They carry the white around with them. And in order to get electricity, you have to pull that white away from that black and stuff the white into a battery. It has no weight to speak of. It just gets stuffed into the battery. And the battery gets charged up, but it doesn't gain any weight. How does that happen? This has no mass to it. It's just amazing. I can't explain it, but that's true. And here's what happens when we put it through the Venturi. The black literally separated from the white and created just exactly what they want to see at CERN and Fermilab. They want to see a sterile muon, which is the black all by itself, and they want to see the electron neutrino, which was the white ball, turn into a shower, which is there. This is it. That's fission. That's fusion. They come back together. And this is acceleration of light. All of this stuff is Einstein says you can't speed up light, you can't slow down light, it's all one speed. That's just nonsense. And we can see these things using CMOS. And we were looking for the smallest particles there is, and light is as close to the smallest particle as you can get. The only smaller particle is a dipole electron, which is that. And that's what they would always consider an electron. However, you can actually split the black from the white, which is, I just showed you, we did. We did all these things that I'm saying. And this is not just guesses. This is the actual pictures of these events occurring. And this is just on steroids, that energy. And I think we can harvest that energy. I've been showing this for many years now. If we could take that energy right there. Anytime you increase luminosity, you increase energy. It started out here, you could almost barely see it. By the time it hit the Venturi, it's accelerated so powerful, and it splits. And all we want is that white. If we can take that white, just dribble it down into the batteries. I mean, at this point, it has no mass. It's just separated, that's the key. You got to rip that white away from the black. When you create energy, when you create electricity, you're forcing electrons away. You're pushing that white particle so hard that it actually leaves its other partners, and it goes by itself as a white particle into your battery. And that's what you want, is that white right there. That's all. And somebody should look into this. This is insane not to look into this. Because if we could harvest that white, that's all you want in your battery, and it has no weight whatsoever. And this has no weight. And that I can prove as well. From an atomic bomb, the first thing that hits is all the white hits. And then the black comes behind, and I can show that happening too. Here it is right here. All the white comes out first through this Venturi, which is nothing more than an accelerator exploder, a crusher of fields, that creates fission and fusion. It's spewing out white particles here because the black is pushing the white. And then it creates what they call a whistler wave out here, which is a sound wave. You can hear it. And behind it is the pulse laser. All right, so that shows that they can separate, and the black pushes the white, and the black never gets big, it never gets small, it's exactly the same size, never changes. And this is a whole row of black. It's a whole row of black here. They're coming here, little bits and pieces. But you can tune this Venturi to either let no black in, or let a lot of black in, or none at all. Like here, there's just none. No black whatsoever coming through here. And I've seen other ones where a lot of black comes through there, along with the white. But and the green does a real nice job of showing that, where they both come through together. So this is an accelerator. This is an energy expander. Whenever you increase the luminosity, which means the brightness, you increase the energy. That's exactly, look it up, figure it out. I mean, there's no question whatsoever, that's a fact. So we're not using these big particles, we're using the tiny particles. Now, getting back to our Earth and about the zones of cold and hot and liquids and so forth, they're saying that this is what they're talking about, the extended disk and the compact disk. In the compact disk, you have watery vapors. In the extended disk, you have these freezing zones and then hot zones, and freezing zones and hot zones. Well, they think it's like a big deal. It's not a big deal. It's just the way it works. Because this is the scrub zone. That's going to get hot. Hot creates the other side is cold. And it bounces. And then it creates hot there, and then it creates cold on the other side. The black is the cold, the hot is the glowy part. It's just very obvious. This was taken with a cell phone, which I don't know what kind of app it was. This is Rod Warren's nephew, Dylan Carpenter, took this. But you can see all of these fields. They're everywhere. Fields everywhere. Particles coming through these are going to slow down. They're not going to continue on without, just like it wasn't there. We have no idea where we are. We have no idea how far things are away, because they could come through all kinds of different intensities of stuff that's in front of it. I showed you the stuff right from Webb. They show it. It's just a complete soup. Okay, look at this. This is the atmosphere layers coming down to Earth. This is way out where space stations and stuff orbit out there. So there's very little atmosphere out there. So there's virtually nothing. But there's a scrub zone right here, below where they are. And at that scrub zone, it can get up to temperatures of 2,700 degrees Fahrenheit to 1,500 degrees Celsius. This layer is hotter than hell. And then what happens then? Minus 80 degrees Celsius. Here is where your frozen stuff is. This is where ice can develop. And that's where hail and all that stuff and the really heavy-duty chunks of ice come out of here. As things get highly compressed, the more compression you have, the more condensation. Condensation is the gases, which is the oxygen and the hydrogens, crushing together, turning into water, which is H2O. Normally the H's and O's floating around by themselves, but when you crush them together and condense them, you get H2O, which is water. So you got chunks of ice out here, and then you just below there, it gets into another layer of heat, and that's where the water forms, and then you get rain. It's as simple as that. They didn't discover anything. I can't imagine what they're thinking. See, they spent 2 months trying to figure this out. They said the preliminary results were telling us that the compact disk, the inner core, had colder water, and the large disks outside had hotter water. Well, they're scrubbing. The inside one is melting from the ice. They say it made no sense. Well, it makes sense to me. All right, and here's the matter that fills the universe. And it's nothing more than gases and dust and all kinds of debris that's floating around out there. I just showed, well, I'll show you one more time the pictures that they show, a series of different shots they've taken from Webb out there that show how much debris is in space. And if they think light just comes through that without slowing down, I can't imagine their thought process. Now out here, as you remember, I saw it's 2,700 degrees. That's 2,700 degrees out here. There's no reason for that whatsoever they can think of. If this was just empty space, it should be cold out there. It shouldn't be scrubbing, and it is scrubbing. So is the sun. And the sun is millions of degrees way out here. It's only 10,000 on the surface. Everything has a coating of electrons and gases and so forth, and they scrub through whatever they have to scrub through, and as they do, they create heat. And the bigger they are, the hotter they get. And as we increase our envelope of gases, which is what happens every time we burn something, it gets bigger and bigger and bigger. And when we do that, it gets scrubbed, more and more scrub out there, harder and harder. That's when you get your turbulence. You get hurricanes, tornadoes, all kinds of violence, big heavy-duty hailstorms. You ever see some of these hail like the size of golf balls, baseballs? And that's coming from that layer, which is really cold, and it gets so condensed that it comes down in these chunks of ice instead of rain. All right, this is some more stuff. Now, this is from another place, Science Alert, and they mimic the exact same stuff. Here it is right here. Webb telescope may have finally confirmed how planets take shape. They all mimic the same words. So I am going to be commenting on these things. The mysterious origin of North America's last primate finally emerged. These are all what they call peer-reviewed, fact-checked. So everybody has to agree, and they're just all coming up with concocted stories to drag you in, like this one here, redshift. I've been commenting on the redshift. It has nothing to do with planets being pulled away. It's light slowing down. That's all it is. That's all it is. And I did my video on this the other day, and I believe they're trying to confront these things that I am starting to speak about loudly. I'm not quiet. And I know I have, and I've presented this to all these same people that are making these statements now. So they're not mentioning me, but I can guarantee you that they fully understand who's talking about this, and it is me, and it's a lot of other people too, because we've been just misled to believe that we're just nothing but slime that came from nowhere, from a big bang of nothing into everything, and all of the things are expanding away from us, and all of these fancy telescopes they have can see through all of these magnetic fields, which they cannot. It's absolutely insane. And there's no way in the world they can defend these claims they're making. Einstein was wrong. You can speed up light, you can slow down light. I've shown all of these things. Hundreds and hundreds and hundreds and hundreds of times, and they just cannot accept the truth of the reality of the truth. This is right from Fermilab and CERN. They say these are the smallest particles. Absolutely, they are. Why won't they talk to me? I could show them how to see these but it's too not expensive enough. It's too easy. So they don't want to get involved. I was told I was a tinfoil hat guy. Stay away. Don't bother us. And spending literally millions and millions and millions of dollars a day to do the things they're doing, and they're getting nowhere. And it's been 60 years, 70 years of nonsense. So here's another one. This is from physics. Science Alert and they're just telling you papers that people are putting out. Most expensive material known to science isn't what you think. Guess what it is? After a journey of 7 years, 4 billion miles, NASA's OSIRIS-REx landed gently in Utah desert with a precious payload. This brought back a sample from the asteroid Bennu, and guess what it is? It's blood. It's blood. I absolutely guarantee you, I know exactly what's in that. It is blood. Blood, because Bennu that they landed on and took it from was a heart, and it still is a heart, and so is Psyche, showing that very, very clearly. These are the things they have to confront to me, and these are things that they have hidden and stayed away. The most expensive material on Earth. It's like billions of dollars a gram. I mean, it's just unbelievable. They spent all that money to go out there and collect out some blood. And when they sample out, and already they announce basically that it is in that range of blood. Now, once they get the details of it, it'll be exactly what I posted before they landed with it. Like $1.16 billion for 9 ounces of sample. That's pretty cheap. You see this? Come up and watch this. This is my claim about the upcoming exam of asteroid Bennu and its biology, easily proven. And this goes back a month ago. And I talked about exactly what they're going to find. This is a heart from Earth. You see these all those little holes? That's the tubing. The same thing is up on Bennu. It's the same tubing. And I showed this so clearly, it's just undeniable. All right, so, and the fossil record, they're talking about bones. Well, Yale has now agreed with me that I have the correct exceptional preservation of soft-bodied creatures from silica-rich oceans. Now, I'm going to leave it at this. Don't forget, this is what they're seeing through, is all these huge particles everywhere. It's just a soup out here. They can't possibly believe that these are coming at us and never slowing down. This is just nothing more than resistance to the light coming at us. As simple as that. I showed light accelerates, slows down, and that's what's happening here. It's all slowing down, and it always ends up being the cosmic microwave radiation background, because the light gets so slow that it just sort of drifts around. It's the background, and it's just a little bit of a glow in the background. That's what it's all about, my friends. And if I can discuss this with some other theoretical physicists that will look at my information and will discuss their information, discuss my information, these light experiments, and then maybe we can get somewhere. But until they will look at my stuff, I'm looking at their stuff, I'm commenting about it, and I'm saying this is not correct. You can't make that light come through to here without slowing it down. It's just not going to happen. That's the redshift. Redshift is not because everything's spewing out so fast that it's pulling it away, forcing it to shift to the red because it's pulling it. No. It's coming at us, slowing down. And then all of a sudden it's in the cosmic microwave background.